Okay, young minds of America, this is your well-rounded math teacher, Mr. Pekar, and we're going to do some solving polynomials today. Actually, what we're doing is we're going to take like this function here and say if it was f of x equals x squared plus x minus 2. Oh, I can't write today. And graphed it, this is what it looked like. Well, where does it cross the x-axis? It crosses at 1, 0, and that means x equals 1 right there, and negative 2, 0, and that means x equals negative 2, where it crosses the x-axis, these 2 points. So if you can break this down, and we're going to break it down using division here, we're going to divide it by x minus 1, and we're saying that's one of the factors of that function. And if you get all the factors, you can set them equal to 0 and solve, and you get your little zeros right here. Hence, you solve the function. So first thing we got to do here is set this equal to 0 and solve. So when I do that, I'm going to add 1 to both sides, and I get x equals 1, adding 1 to both sides. And that 1 is what goes in the box. Then you list this out, constants and coefficients. That's 1x squared plus 1x minus 2. So listing all those numbers, 1, 1, and negative 2, don't forget the negative, we kind of begin our process here. So this is what we learned last week now. You always bring that first number down, 1, and then you multiply it by what's in the box. 1 times 1 is 1. We always add these columns up. 1 plus 1 is 2. And then we multiply by the 1 again. 1 times 2 is 2. So I'm going to bring that over here. Add that column up. I get 0. And that is my remainder. So what we're saying is this x minus 1 divides in there evenly. Okay? So what do we have here now? What's our answer? Well, just to the left of my remainder, that's the constant 2. And just to the left of that 2 is the first x term, 1x, so that's x plus 2. So basically what I'm saying is, this is my answer, x plus 2. This is what I divided by, x minus 1, okay? And if you take all the factors, so if I multiply these two, I'd have this function up here. If you take the factors of that function, and we're saying x minus 1 is one of them, and x plus 2 is the other one, you just set them equal to 0. X plus 2 equals 0. If I subtract 2 from both sides, I get x equals negative 2, and that's my first 0 right there. And if I take what we divided by and set that equal to 0, we already solved that. We added 1 to both sides. We get x equals 1, and that's that one right there. So just break them down using division. We might have to factor. We're going to have to factor for this next one here to kind of see where that's going. But that's what we're doing today, using synthetic division, taking our factors, finding all our factors, and then set them equal to 0 and solve to find where it crosses the x-axis. So we're going to do this one too. They're saying it's divisible by x minus 1, so this is one of my factors right here. If I solve this, I add 1 to both sides, and I get x equals 1. Well, that's one of my solutions right there. When we do synthetic division, what we're left with, it's going to give us the other two factors. And we got to work to find those ones a little bit. So we're showing you this picture to kind of show you what's going on here. So we're just going to plug the one in the box over here. This is in degree of decreasing order. X cubed, x squared, x, and then a constant. So we're pretty good to go right there. We just need to take all those numbers. That's 1x cubed minus 4x squared minus 1x plus 4. So we got 1, negative 4, negative 1, and positive 4. And we're going to use synthetic division to break it down. We're going to have to factor this one. I'll show you that in a minute. So 1, bring down the 1 first of all. You always bring that first number down. 1 times 1 is 1. We always add up the columns. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. Adding that up, I get negative 4. Remember, always add these columns. 1, take that number in the box there. 1 times -4 is -4. If we add up this column, we get 0. It divides in there evenly, and it should, because we're saying this is one of the factors, okay? So I'm going to do it this way. We started with an x cubed, so this first one here, which is part of our answer, is going to be 1 degree less than that is x squared, so that's going to be 1x squared. You can put the 1 in front of it if you want. Minus, going down now, 3x minus 4. If you went the other way, -4 would be your constant. There it is. And then the first x would be x to the first. That's -3x. That's down there. And then 1x squared. So it doesn't really matter which way you go. There we go. Okay? But the deal with this is these are not factors. This is a polynomial of degree 2 right there. We need to factor this. We need it to look like this right here, an x minus 1, x plus 2, x plus 3, x minus 4, whatever. So we got to break it down. So we are going to factor it. It's a general trinomial. I'm going to use the little x method first. Take your 1 and multiply it by -4. And that's going to give me -4. I need factors of -4 that add up to that -3. Let me write that a little bit better. So I could go with 1 and -4. Well, that adds up to if I multiply them, I get -4, and if I add them up, I get -3. So it's 1 and -4. And those are going to become my x terms. So let's kick in the box method here, shall we? We shall. Okay. So plugging in, you always take that first term, x squared goes right here. Take your last term, -4, if you remember factoring, it goes right there. I'll put the 1x in here and the -4x in right here. So going across, first of all, x and x squared, well, they just have an x in common. -4 and -4x, well, they both have a -4. So that's going to be my first factor, x minus 4. Boom. The other one looks like this column right here, x squared -4x. I can just take out an x. X times x is x squared. Here I just have a 1, it looks like, and this x times 1 is going to give me 1x, and this 1 times this -4 is going to give me -4. So it looks like it works. So I got x plus 1 as my other factor. And then we had this original one up here, x minus 1. So those are all the factors now. We got the first two by using synthetic division and breaking that down by factoring. If you take all of them, I'll do it in blue so it kind of sticks out here a little bit. I'll take this first one, x minus 4. And if you set that equal to 0 and solve, I'd add 4 to both sides. I get x equals 4. And I should, there it is, 4, 0. X equals this 4. That's my first 0. Take x plus 1, set equals 0 and solve. I'd subtract 1 from both sides. I get x equals -1. And there it is, x equals -1. That's one of my other zeros. And then the x minus 1 that we had to begin with, that's what we divided by up here. If you set that equals 0, you'd add 1 to both sides. You get x equals 1. It's basically the same number that goes in the box. But there it is, 1, 0, or x equals 1. So we can use synthetic division to break this down to find all our factors, given one factor to begin with, and find where it crosses the x-axis. And that's what we want you to be able to do today, okay? So let's practice breaking another one down. And for this one, it's just asking, given one factor, here it is, x plus 3, that's what we're dividing by. Use division to find the remaining factors. So it's x cubed, so you need 3 factors altogether. If it was x to the 4th, my leading degree or leading term, I'd need 4 factors, but we need 3, and we're given 1, so we only got to find 2. So it's kind of going to be like this last problem. It says write your answer in factored form. Okay, we'll do that. Okay, so x equals 0, or x plus 3 equals 0. Solve. I get subtracting 3 from both sides. I get x equals negative 3. So if I had an xy axis over here, 1, 2, negative 3, that would be one of my zeros. Anyway, just so you kind of know what's going on. I'm going to put negative 3 in the little box here. We have x cubed, x squared, x, and a constant, so it's going in degree of decreasing order. So I can just list those out. Be careful not to forget negatives. There was only one negative here, and that was negative 15. And skip a little space, draw a line, and go right into it. Always bring that first number down, okay? Negative 3, excuse me. Take your number in the box, that's negative 3, and we're going to multiply it by that 2, negative 6. Always add up your columns. 15 and negative 6 is 9. Negative 3 times 9 is negative 27. So that when I multiply it, it goes up here just like that negative 6 went up here. Adding my column up, I get negative 5. Negative 3 here times negative 5, that's going to give me positive 15, so I'd put it right there. And it goes in there evenly. My remainder is 0. And it should, because we're saying this is one of the factors, okay? Anyway, let's keep going here. Well, we didn't divide by anything, so this is going to be my answer straight up. It's x cubed to begin with, so my first 2 in my answer is going to be 2x squared, 1 degree less. So the next one is going to be plus 9x, and then x squared, x, and then a constant, minus 5. So I got one factor, x plus 3. I'm going to write it right here. That's what we divided by. We got to find the other 2 factors in our problem right here, our answer. So we got to get factoring. This is a general trinomial, x squared, x, and a constant. So I'm going to take this 2 and multiply it by negative 5. That's going to give me negative 10. Use that little x method. Factors of negative 10 that add up to 9. Okay, so I could do 1 and negative 10, but that adds up to negative 9. I want to add up to positive 9, so how about negative 1 and positive 10? And that does work. So negative 1 and positive 10. If we're going to use the box method here, and we are, you could use grouping 2. Maybe I should do a grouping 1 to show you that, see if you can remember that. What are we going to put in the box? First term, 2x squared goes here. Last term, negative 5. Okay? And then these are my x terms. I'll put the negative 1x here. Doesn't matter. I could put it down here where the 10x is, but we'll go like this. So, excuse me. Let's go back to black here. And top row. What do they have in common? 2x squared and negative x. I would just say they have an x in common. Here it looks like they have, looks like a 5. So I think one of them is going to be x plus 5, but we got to kind of check this. Here, the 2x squared, that column, and the 10x, well, they both have an x, and it looks like a 2. And x times 2x is going to give me this 2x squared. X times what is going to give me the negative 1x? Well, that's negative 1. And negative 1 times this 5 down here is going to give me the negative 5. So it looks like it works. So this factored out is going to give me 2x minus 1 and the x plus 5. So it says list all the factors. Well, I already got the one we divided by, and that's x plus 3 right here. I'm just going to bring these 2 up. 2x minus 1 and x plus 5. And if it said find the zeros, I just set them all equal to 0 and solve, and that's where it would cross the x-axis, kind of like it did up here. You could set them all those factors equal to 0, and you could find where it crossed the x-axis. But they just wanted the factors here. So there we go, okay? And that's it. Your worksheet says, look at the graph to the right. Do you think that this x cubed minus 6x squared plus 3x plus 10 can be divided by x minus 3? Why or why not? Well, it doesn't look like any of these are equal to positive 3, so probably won't. It says divide by one of the factors then and write your answer in factored form. Well, if these zeros represent this function right here, this isn't going to work. So I would say take one of these. If it's -1, 0, that means it came from x plus 1. You could use that as a factor and then divide that into here, and that's what they want you to do for A. So just so you kind of know what's going on. And then the rest of them, what does it say? Given one factor, use division to find the remaining factor. So you're going to kind of do just like we did with this last problem here. Divide by that x plus 5, and then whatever your answer is, some x squared, x and a constant, whatever that is, and then factor it. And that'll give you your other two factors. So that's kind of what you're looking for. So there we go. I'm going to let you guys work, and we will see you next time. Goodbye.